So this is promoting Kubernetes CI/CD to the next level. This talk is going to be about how we do CI/CD within IBM Cloud Private, which is the product that I work on for IBM. It's a kind of our own Kubernetes distribution. So it's about how we actually build and test and deploy full Kubernetes clusters, right? Not just applications into a running cluster, right? So I think this is very applicable to anybody that, I know there's not a lot of people that actually build their own Kubernetes distribution, but I think the automation practices that I'll talk about here are very applicable to anybody that's adopting Kubernetes. I come from a very DevOps background, been doing DevOps, I guess, for about 14 years now. And I will tell you that the principles for how we deploy applications, which Kubernetes takes care of a lot of that for us, right? With the readiness probes and liveness probes, we can start treating our applications like cattle rather than pets, right? That's a very famous term. The problem is that if we now shift and start treating our Kubernetes clusters like pets, then we're kind of defeating the purpose, right? So automating your Kubernetes installation, being able to stand it up immediately on demand, whenever you want to, wherever you want to, is a very important principle for anybody that's going to be running any sort of CI/CD DevOps practice with a Kubernetes application. But that's not specifically what I'm going to talk about today. Specifically, what I'm going to talk about is how we do CI/CD internally within IBM. So just a quick little agenda for the day. Talk a little bit about who I am, what my background is, what IBM Cloud Private is, and how we got to where we did. And then we're going to start looking at DevOps principles for shrink wrap software. And this term might actually date me a little bit. For the younger crowd, shrink wrap software is the software that used to be sold in a box on a shelf, and it was shrink wrapped. I know nobody does that anymore, but that's kind of what I mean by shrink wrapped. It means it's for sale. It's like off the shelf kind of software. It's not custom built. There's so many topics to cover in what we've done over the last 18 to 24 months that I'm going to focus in on just 3 main points, which is automation, shift left, and culture, because I think these had the most impact within the organization. So my name's Tim Pouyer. I am the DevOps and SRE leader for IBM Cloud Private. That is not a title I recommend anybody getting unless you want a lot of people to reach out to you on LinkedIn. It's really kind of a misnomer. I run the CI/CD squad. I'm the lead architect for our CI/CD squad within IBM Cloud Private. And then I'm also the squad lead for our SRE team. I've been doing CI/CD deployment automation DevOps for about 14 years. I've traveled to over 60 countries worldwide. And actually, it's my first time in Shanghai, though. And I am a Boy Scout, which is kind of weird. I like being outside. I don't know if you can tell by the way I look. I like to be outside, but I spend a lot of my time in front of a computer. Another interesting fact is I will be going to Shanghai Disneyland while I'm here, which will complete my tour of every single Disneyland in the world. So I'm excited about that. All right, so what is IBM Cloud Private? So IBM Cloud Private is an on-prem Kubernetes distribution. It's really intended to be used as a private cloud in enterprise data centers. It's basically IBM's flavor. Well, I won't say IBM's flavor. It's IBM's distribution of Kubernetes for on-prem support, right? It has enterprise security and governance capabilities that are kind of built in. We do quarterly releases. So every quarter we do a release. So we can try to keep up with the open source version of Kubernetes. That's really hard to do, but we try to keep up with it. We've integrated over 200 open source tools and products within to Kubernetes to have these enterprise capabilities. And we have about 180 developers located in about 4 different countries, including a lab right here in China. So we have a lab in China, a lab in India, a lab in Ontario, Canada, and then 2 labs in the United States. So how did we get here? Well, this started out as a small project in the Ontario lab and grew from there. It was a couple dozen developers that were putting together their own Kubernetes, I don't want to say distribution, but they were cobbling together Kubernetes and writing their own installer to make it easy for customers to stand up and run Kubernetes. It was a very customized piece of software at the time. We grew from that small group of developers into almost 200 developers. And we went from, in the order of magnitude of tens of Docker images to literally hundreds of Docker images. We did this because we kept adding more functionality to the distribution. And then we also added support for PowerPC and S390X. So S390X is IBM's Z mainframe, right? So we can run Kubernetes on Z, on Power, and on x86. We also added 600 customers in 2 years. That's a massive amount of growth. I don't have statistics on the number of lines of code that we've added. Obviously, we adopt a lot of the open source from Kubernetes, but we have our own kind of management layer on top of that. So there's just a lot of different moving parts that go into how we pull this together. So, so DevOps, was our kind of solution, which is why they brought me in, to basically try and implement a DevOps principle or mentality for our process. Right? Our process was largely still the process that was written by a few devs that were in Ontario, right? That was mainly focused around, I want to build this thing from my laptop, right? And that's great when you're a small dev team, right? Of very talented people. What happens when you become, 180 people in 4 different countries and 5 different time zones is that doesn't work anymore, right? You have to coordinate. You have to bring all these pieces together that are getting built at all different times, and you have to make sure that it all comes together and works and is tested and validated before it ever goes out the door. So there are way too many topics to cover in DevOps, since nobody's actually ever really defined it. So I'm going to focus on these 3: automation, shift left, and culture. All right. I think everybody knows what automation is. Shift left, I'll explain a little bit more, but that's the idea of taking things that you would normally do towards the end of a release process and doing them earlier on, right? So some of the testing that you would do at the very end of right before a release, we really want to shift that to the left. We want more of that to happen, immediately after the code is built, earlier in the process, so we can identify the issues and get them resolved quicker. And then culture, right? And I'll talk a little bit more about that. Whoop, too far. So, did I go too far? 1 second. Yeah. All right. So, when I joined ICP in January of 2018, so a little over a year and a half ago, my first focus was automation, right? We've got to automate as much as possible. Like, that's a core principle of any DevOps or CI/CD process, is to automate. So we had a few guiding principles in our automation, right? We wanted it to be push button. We wanted it to be full stack, right? Our product bundles in an installation via Ansible scripts into a Docker image to make it easy for you to install the software, but it does nothing about provisioning infrastructure, right? So we needed the automation to be full stack, provision the infrastructure from start to finish, and then we also needed it to be easily shared, easy to use. We needed to have familiar tooling, and by familiar tooling, I mean the developers needed to understand the tooling kind of inherently, and then it needed to work across all the architectures. So these were kind of our guiding principles of what kind of automation we could build. So what we ended up coming up with is we actually forked a project that was out on GitHub by a group of people called Cloud Posse. It's called Build Harness. And what this does is it utilizes Make. So all of our developers were already using Make to build all of their components, right? And Make's been around for years. It's kind of one of those, if you understand it, everybody thinks you're a genius. And if you don't understand it, then you're just like everybody else. But makes a great tool, and it works across all the different architectures, right? And what Build Harness gave us was the ability to create a set of shareable make targets that we could store in GitHub. And then all our developers have to do is include a single include statement in their make file. And by doing that, they have access to a shared set of pre-built, predefined, tested and validated make targets that do all sorts of things. Let me show you real quick. So this is, no, it's not. 1 second. Let me make sure I got my display on, right? There we go. All right, so this is an example make file sitting in an example build template, right? It's a build project that we set up on our GitHub. It just sets up some generic properties. These are configurable for everybody else. You can see that I only have this one include statement. Well, I have other include statements, but those don't do anything. So this include statement here pulls into our build harness, our fork build harness. And with that included, then I can start to do fun things like make help. And you can see that I get a list of all these targets that aren't in my local make file. They're actually in the make file they're in the make file out on GitHub. Make that bigger. You can see it. All right, so with that, I now have these shared make targets that anybody can include in their own make file to build on top of the logic that's already there, right? This is a great project because like GitHub, where people go and they build their code and they put it out there for others to share, and then communities can come and develop across those and enhance things and make them better. That's exactly what this build harness does, right? A lot of these targets are shared across, well, all of them are shared across all of our development organization or all of our squads. We have about 30, maybe 30 squads total. They can use any of these make targets in their own make file. And we've seen some of the squads contribute some targets that weren't in here to the build harness, and now all of a sudden they start getting shared. So we have linting, we have stuff to build Docker images, we have stuff to build helm charts and all sorts of fun targets, right, that all of our squads can use, and you can stay up to date that way. We also implemented all these deploy targets. So as you can see, we can deploy across AWS, OpenStack. We even have a Vagrant one, vSphere. There's even an Azure in here somewhere. Let me move back. So all of these combine into this include in our build harness, which basically makes all the automation that the CI/CD team has written using Terraform available to all the squads. So when a squad is developing their particular service, they can build their Docker images, they can build their Helm charts, they can push them into Artifactory. Artifactory is what we use as our artifact repository. And then they can deploy them all from just simply including this build harness into their own make file. So this gives them access to be able to test their deployment against AWS or against IBM Cloud or OpenStack or VMware, and even test against the different architectures. So Z, PowerPC, and x86, all accessible to them. It's all done exactly the same across all the squads. Nobody has a custom deployment. It's all maintained at the CI/CD level. And of course, we do take contributions from our squads. So like I said, we had to support all of our different cloud providers, right? The way we executed on this was Terraform. Terraform combined with the Ansible that was already in our installer made it very simple for us to use Terraform just to stand up the infrastructure. And then we wrote a Terraform module to call our installer to actually execute the installation of the infrastructure that we stood up. We also added capabilities within the Terraform to be able to hand different topology deployments within these cloud providers. So HA, non-HA, including GlusterFS or Ceph-Rook. And we continue to add more and more options to those Terraforms. Some of those Terraforms are available publicly on GitHub. Some of them are still internal, and we're working on open sourcing them. So we utilize Artifactory for our packaging of Docker images or storing of Docker images and Helm charts. I really like Artifactory for a couple of reasons. Number one, it gives me the same repository that I can use for both Docker and Helm. Number two is that we use, and I'll talk about this in a second, we use a promotion pipeline. Promotion pipeline allows us to put gates, quality gates within our process. And Artifactory just makes that a lot easier. If any of you have ever tried to do a promotion pipeline with Docker images, the one thing you're going to find out is that as you start to automate that and you run Docker pull, Docker tag, Docker push, well, if you do that across one image that's 10 megabytes or 20 megabytes or 30 megabytes in size, it's not a big deal. But if you have 300 images and they're averaging between 250 to a gig in size, 250 megas to a gig in size, well, then now all of a sudden it takes 6 hours to do that. And what Artifactory does for us is it allows us to run a set of REST calls that just change a pointer in Artifactory. So when we promote from one repository to another, all we're doing is telling Artifactory to change the pointer, right? And it runs orders of magnitude faster, like 20 minutes instead of hours. We also, most of our services run as Helm charts, so they're deployed as Helm charts. And we've written a bash script that can identify the Helm chart and then identify each Docker image and their tag within the Helm chart. And so what that means is that as we start to promote builds through our pipeline, we can run that script against the Helm charts that we've deployed successfully, and we know that they work, to identify all the Docker images and the tags that need to go along with the Helm chart. So it's kind of like it allows us to build a manifest of all the Docker images and the Helm charts that need to be promoted at once. So shift left. So I spoke about this a little bit earlier. Shift left is the idea that I want to take certain tasks like canary deploys, integration tests, functional tests, vulnerability scans, Docker image scans, and instead of running them right before the release, I want to run them much earlier in my process. By doing this, I can identify issues earlier on when it's easier to fix and easier to resolve than rather at the end of a release where all of a sudden it's a fire because I've noticed this problem and now I've got to go back and somehow fix it quickly. So this really works well when you use promotional stages. And I know that you'll probably see, if you read on Google or you Google it, that using promotional stages with Docker images is they might even say it's an anti-pattern. And that's probably for the aforementioned, the before mentioned problem of having to download the Docker image and retag them and upload them. It just takes too much time. Artifactory kind of eliminates that for us a little bit. By using the stages, promotional stages, we actually get to put a process on our release, right? So it's not just everybody's building something at all different times, and we never know exactly what state the product is in at any given time in the release. We can actually tell just from our stages. So we start at scratch, which is where all of our PR builds go. Integrations where our master builds go. And these are updated continuously. We have, like I said earlier, we have squads that are in China and in India and Canada and the United States. So all different time zones, these particular repos, like integration, is changing all the time, continuously. Which is great, except for when you need to test something. Because if you deploy out of integration, you don't necessarily know what you're deploying, right? Because it can actually change underneath you. You could go through the deployment, and by the time you get through the deployment, which takes about an hour, hour and a half, and you start testing, which takes another 30 minutes, and then you get your results back, you may find that there was an issue, but you go back and look at the image, and it may not be the image that was actually deployed when you were testing it. So the way we solve this problem is we use a daily repo, and twice a day, I know it sounds stupid because it's a daily repo, but twice a day, we run a promotion process from integration. We're basically just taking a snapshot out of integration, right, and moving it into daily, and nobody has access to that except for our CI/CD squad. And then we deploy, our canary deploys out of daily to validate what we've seen in integration. This gives us the feedback of where we are exactly in the process, what's working, what's not working, and we can go back to our squads and say, you have a specific problem, you need to get it resolved. Sometimes they tell us, oh, we've already fixed that, we pushed an integration, great, we'll promote that up, we'll run the canaries again. So the stages are very important for us to understand where we're at in our cycle, in our release cycle. And like I said earlier, the stages also give us the ability to implement quality gates. So, you know, whenever you're producing a product, whether it's a car or, you know, a t-shirt, right? There's usually somebody that inspects it for quality, right? And everybody should know that you should be running some degree of quality testing on any software before you release it to the public. What we do is we utilize our staging process, our promotion process, to enforce quality gates. So like I said, we go from integration to daily, once a day, that's a scheduled, or twice a day, that's a scheduled process. We run canaries out of our daily repo. We then execute regression tests against that deployment. And if it all passes, so basically every cloud provider we support, we're running canaries on, and then we're running regression on every cloud provider. If it all passes, then we will promote to Edge. And Edge is the first stage in our promotion pipeline that everybody within IBM has access to. So because we use Artifactory, and because Artifactory is offered within IBM as a SaaS offering, it's basically a software as a service, everybody within IBM has access to the repositories in Artifactory if you make them public to IBM. So Edge, Stable, and Release are all public to IBM, and anybody can download them. So from daily to Edge, we are running canaries and regressions. We run promote from Edge into Stable at the boundaries of our sprints. So we break down into sprints. At the end of a sprint, we will get something into Stable, which suggests that it's a slightly more stable API, less changes going on between sprints. And then finally, we have release, right? And at each of these stages, we have different criteria for how you promote from one repository to the next. And if it doesn't pass, then we don't proceed, right? So by exposing these repositories to IBM, basically IBM Cloud Private is a platform, right? And we have lots of consumers of that platform within IBM. So we have lots of middleware products that are being containerized and made into Helm charts and made available in Helm catalogs, right? We call that our content teams, okay? Our content teams want quick feedback, right? So they want to be able to deploy their content onto our latest Edge builds and discover if there's a problem, if we've broken some of their API that they were using, or you know, we've introduced some new Kubernetes API that they would like to use. So they can pick up these builds out of Edge on literally a daily basis. Sometimes we don't get something into Edge every day, depending on how our canaries deploy and how we do on that. But the sooner we can get it to them, then the sooner they can give us feedback. And what that creates is this sense of, we might have a good idea out of development, our content teams might pick that up and say, you know, we like the idea, but it would be better if you did it this way, right? And good ideas become great ideas based off of that shortened feedback loop, right? We also utilize Slack internally. All of our squads have their own channels. So if there's a particular problem with a particular API or particular service, anybody can go to that channel and ask questions and get feedback. CI/CD also runs their own channel where we communicate to the development organization as a whole, whether canaries are passing or failing, or we need assistance with something we couldn't figure out. So we all utilize Slack in that way. And then we also utilize GitHub. All of our issues are opened in GitHub, and anybody can open up an issue. Anybody within IBM can open up an issue on GitHub, and that's how we track improvements to the product. So all that is focusing on shortening that feedback loop and shifting everything left. So culture is the last focus area I want to focus on. And I'm not talking about differences in nationalities. Like I said earlier, we have labs in China, we have labs in India and in Canada and North America. So it's not a difference in nationality that I'm talking about here. Culture really has to do with how we change what developers are used to doing, right? And it's not just developers, it's everybody. It's managers, it's offering managers, it's development managers, it's the salespeople. I mean, culture it goes across the board. It's hard to change, right? It's hard to change a culture. Once something gets kind of set in stone, then it's almost like fighting, an endless battle. Developers don't like to give up control. That's a given. They don't like to change their processes. Even if their process doesn't make sense, they don't like to change it. Managers want to ship product, and nobody wants to miss a release date, right? These are all things that you kind of have to fight against when you start to put a CI/CD process in place. So, like I said earlier, we forced all of the squads to give up control of not their particular builds, but of the build of the product. So every squad still owns their individual build process for their particular service. So they're still building their Docker images, they're still building their Helm charts. The CI/CD team is controlling the process once they contribute it to integration. So the assembly of the entire end product is being done by the CI/CD team. And that was a bit of a challenge to get developers to give up control of that. And I would say that in small teams, that process, that kind of dev owned, I'm going to build this thing on my laptop and it's going to be great, works. But in large teams spread across time zones and countries, it becomes unmanageable because you never know where you're at in your release process. So CI/CD owns the combined process. And I put a little picture of a train on here because we really treat it like a release train, right? So with the promotional stages and the quality gates and all the testing and automation that we're doing, it is a release train. You get on the train if you want to get released, and if you're not on the train, you're not getting released, right? So the hardest part about changing culture is probably going to be spending time, right? You got to spend time to educate why you're doing things. Why are you changing the process? Because the developer is going to fight against any sort of process change. And managers and release managers will also fight against process change. So you've got to spend the time to educate people, to let them know why you're changing it, what the process is, how it works, how it'll flow from end to end. Not just how, but also why. What are the improvements, right? So the promotion pipeline that we put in place, I had to spend a lot of time explaining to people why it was necessary, what exactly it did, what were the quality gates, what were the criteria for moving from one stage in that promotion pipeline to the other, right? So that was a lot of time, and it takes a long time when your team's spread across, 5 different time zones. You got to stay up really late at night to have meetings with people in China, when you're explaining why this is working the way you want it to work. So you need to make sure everybody understands the process. This is very important, right? Making sure everybody understands the process, because just knowing the how without the why is going to cause you a lot of problems later on, especially when you get close to a release, and that process tends to speed up as we get closer to release. And then you start getting tons of questions about why. So make sure everybody knows why. Trust the process. It's going to be tough if you implement something like this and you're trying to change a culture. It will be tough. It's going to challenge you. You have to be strong in your resolve, and you just know that the ends will justify the means, right? So I just want to take 1 second to call out Andrew McNamara, who is leading the CI/CD squad. He's the squad lead for CI/CD. He was originally supposed to be here to give this talk, and his wife is pregnant with twins, due any day now, so he unfortunately couldn't come. But I wanted to call him out and give him credit for the great work that he's been doing with the squad, and helping me out with this. So with that, any particular questions? No? Okay, well, thank you. Appreciate it.